Hi there, welcome to this video on graphing rational functions. This is lesson 3 in unit 4 for integrated math 3. We're going to go over basic translations for rational functions and maybe even throw in some reflections. There will be a part 2 video where we get more into the stretch and compressions. So here is our learning target, and you'll be successful if you can identify parameters. Those are the a, h, and k. If you don't know what a, h, and k is, make sure you go back and watch lesson 2 where we talk about that. You can graph and identify the vertical and horizontal asymptotes of a rational function, as well as plot the transformed key points. Okay, so we are going to go ahead and, for prior knowledge, determine the equations of the asymptotes. Remember, rational functions have a vertical asymptote which goes up and down. So here is our vertical asymptote, and that equation is x equals -2. Remember, vertical lines are always x equals, kind of the change from the y-axis, which goes up and down. Horizontal asymptote, this is a horizontal line where we always have y equals, and it's always that y value. So there, that y value is equal to 3, okay? So we are going to go ahead and graph these rational functions. And again, here is the parent function of a rational function. And notice the parent function has a vertical asymptote at 0 and a horizontal asymptote at y equals 0. And we have these key points, -1 and +1. And what we're going to go ahead and do is we're going to transform this. Given a rational function with this form, f of x equals a over x minus h plus k, we're going to add an h value and a k value. Remember, h moves our graph left and right, and whatever we add in as a h value moving left or right, that's actually going to be our vertical asymptote. The k value will shift us up and down. So whatever that value is, that will be our horizontal asymptote, y equals k. Okay, let me go ahead and show you kind of how that looks. Okay, so here is Desmos, and this is what a rational function looks like, and I'll just go ahead and add an h value. So let's say h is equal to 2. So what I want you to notice is how we move to the right 2 units, and that's exactly where my vertical asymptote is. So your vertical asymptote will be x equals whatever that h value is. Your horizontal asymptote will be determined by the k value. So if my k value is, let's say, -2, then I'm shifting down 2 units, and that's where my horizontal asymptote will be. What I want you to notice is through these translations, the relationship of our anchor points does not change. I still go left 1 and down 1, right 1 and up 1, okay? And so what we'll do today, this will generally be our kind of like step process, is we'll determine a, h, and k, and then we'll graph those asymptotes as dashed lines. Then from there, we'll plot our key points. So 1, 1, -1, -1 from the transformed asymptotes. So I go right 1, up 1, left 1, down 1, okay? And the only way that these points will change is if we have an a value. And so for this lesson specifically, I think our a value might be -1. We might have this. And if that happens, just notice that they reflect, okay? Instead of going left and down, I go left and then I go up 1, right? That y value was multiplied by a -1. Same on the right side. Instead of going right and up, I go right and then down 1, okay? Because again, that y value was multiplied by a -1. So that is kind of generally what we do, and then we'll draw our pieces of the curve through those points. Now, what I want you to notice is that these rational functions, they approach our asymptotes. So at the infinities, we start at our horizontal asymptote, and we work through that point, and we go towards our vertical asymptote. Notice that this function is monotonic, meaning it only increases or decreases. So don't do any like squiggly lines in here. It's got to be strictly increasing or decreasing. And also notice the concavity is consistent, meaning I'm always opening up. Okay, I never go ahead and kind of change the inflection of that curve. Okay, same down here. This is always concave down. So I'm increasing, concave down through that point. All right. So let's go ahead, let's check out an example. Here is example number 1. They say graph the function, write the equation of the asymptotes. So g of x equals 1 over x plus 4. I like to identify A, H, and K just because it is good habit. And here we can do this. Okay, so A is 1, H is 0, and K is 4. What this means is it means that my vertical asymptote is 0 and my horizontal asymptote is 4. Okay, so I'm going to go ahead and note that here. Okay, I don't have any horizontal translation, so I'll leave my vertical asymptote right at 0. And the horizontal asymptote is moving up 4 because we have a K value of 4, shifting our whole graph up 4. So when we go ahead, that's really step 1, okay, and then graphing the asymptotes is step 2. Step 3, you're going to graph your key points. And the key points really are simple. -1, -1, 1, 1. So they're always going to be mirrored from the intersection of your new asymptote. So left one, down one, right one, up one. And again, the only thing that will change is if our A is negative, we'll reflect, we'll go down, okay? So I'm going to go ahead, and here our A value does not change. So my key points, left one, down one, right one, up one. Okay, so there's my key points, and then our curve will go through these points. Okay, so where those points are, that's the quadrant your curve is going to be in. So I'm going to go ahead, I'm going to start near my horizontal asymptote, I'm going to approach the point, and I'm going to curve through it nice and smooth, and then I'm going to approach down towards my vertical asymptote, okay? Notice I'm constantly decreasing, I'm always concave down, right, opening downward. And then the same up here, okay? Start at my vertical asymptote, and I'm going to go through this point, and then I'm going to approach my horizontal asymptote. Never cross your asymptotes, never cross them. That's how you know you did it wrong. If you cross over the asymptotes, you should stay in these, I guess, kind of new quadrants. Let's look at example 2, where in example 2, we now have a negative A value. Okay, A is equal to -1. We finally have an H value, which is -3. Remember that the H is always opposite, and our K value here is 0. I don't have anything tacked on at the end. So what does that mean? Well, it means that my vertical asymptote is x equals -3. We got shifted to the left 3. And our horizontal asymptote is on the x-axis as such. And then now for my key points, again, my key points, I have -1, -1, +1, +1. But I'm multiplying by A. We always multiply our y values times A. So I multiply this by a -1, and a negative times a negative is a positive. And a positive times a negative is negative. So now what this says is, hey, when you go left 1, you need to go up 1. Left and then up. And that should make sense, right? Because I have reflection. A is negative, so we reflect. And the same thing over here, right? So I'm going to go right 1, down 1. So right 1, down 1. And we always, again, graph these values from the intersection of our asymptotes, okay? So let's go ahead and now draw our curve. Smooth curve, you got to be smooth. Okay, there's our curve. And then down here. Voila, there is your transformed rational function. Pretty easy. Identify H and K, graph those asymptotes, and then graph that key point, -1, -1, +1, +1. But if you have an A value, you got to multiply by it. All right, so there's those two examples. I want you to go ahead, pause me. I want you to try this practice problem. Let's see if you get it. Okay, here is this example. Your A was 1, H was 2. Remember, it's always the opposite. If you're going to mess up, that's what it's going to be. You should have gone right 2, not left 2. And then K is 0, so there's your asymptotes. And then your key points don't change. Left 1, down 1, right 1, up 1. Okay, so that's what it should look like. Did you get it? Cool. All right, final example I have for you guys here. Just really nothing too crazy, but we have finally an H value paired with a K value. So we have both the translations horizontally and vertically. So vertical asymptote is 5. I'll go ahead and graph that. So there's 5. And our horizontal asymptote is -2. Y equals -2. Yes, please write the x equals 5 and the y equals -2. So there we go. There is our asymptotes, and then I'm going to plot my points. Again, my points, here A is just 1. I don't have transformations, reflection, So left one, down one, right one, up one. And then we'll go ahead and draw our curve. There you go. Start at the horizontal asymptote, work through the point, go down to the vertical asymptote, and then from here we go vertical asymptote through the point, out to the horizontal asymptote. If you want to reverse it and always start at the horizontal asymptote and work towards the vertical asymptote, you can do that, but never cross the asymptotes. Don't do that. Okay. Some practice problems here. Let's go ahead, please pause me, try this example one, or this practice problem, and then I'll go ahead and I will show you the results. I'm trying to make it full. There we go. Okay. All right. Pause me. Try this one. Okay. Here is the solution for this practice one. Your A value is -1, so you do get that reflection. So hopefully you reflected over, right? The Y values should multiply by negative. And then your H value is 0, so you don't change or translate your vertical asymptote, but we do have a K value that is -2, so we translate down 2 units. Did you get it? Good job. All right. Last example. Go ahead. Oh, wait. The other thing I do want to say is try not to graph here, make this look like an L, like no 90-degree angles. It needs to be a curve, right? So no straight up to the point, straight over. That would result in a docked point, at least if you're in my class, and most probably other math classes. Okay, so pause me, try this example. Okay, and here is the solution. You should have an A value that is -1, so you get reflection. Your H value is -4. Remember, it's the opposite. If you're going to mess up, that's probably where it's going to be. So we go left 4, and then our K value is 3, so we're shifted up 3. This one had everything, okay? But here is what it looks like. Make sure your graph does not look like L's, okay? No 90-degree angles, and did you approach your asymptote? You shouldn't cross over them, okay? All right, so hopefully in this video you learned how to graph rational functions. I'll catch you next time. Give me a thumbs up if you learned something. See you later.